Today we're going to talk about the last reaction of amino acids, which is the condensation of amino acids in order to form peptide chains, which actually form proteins. And the concept is very simple. We know that the basic structure of the amino acid is as follows. We have a carbon atom, an amino group, a carboxylic group, and an alkyl group, which is basically the more carbons that we add in order to form the amino acid. But this is the basic formula. So in order to add up more amino acids to form a longer peptide chain, we will remove the hydroxyl group off the carboxylic group, and for the next amino acid having the same structure as this one, like this, we will remove a hydrogen from here. So technically we are eliminating a water molecule, and the bond will be formed like this. So we have a carbonyl group bound to an NH group, and this is how the bond is formed, and the amino acids start to add up like this. From this we can see that we have two ends for the peptide chain. We have an amino end and a carboxylic end. And usually when we write the amino acid, for example, the amino acid in the peptide chains, for example, if you have a peptide chain formed of alanine, glycine, and cysteine, so we conclude that alanine is at the amino end and the cysteine is at the carboxylic end. This is the concept of the condensation of amino acids. But there is an exception, which is glutathione, or GSH. This peptide chain is a little bit different from the other peptide chains, because we write it like this: gamma, glutamic acid, cysteine, and glycine. So what does that mean? What is the gamma? In the first example that I mentioned, I said that the binding happens here. This is the alpha carbon. This is the alpha carbon. But in case of the glutamic acid, we know that we have an extra carboxylic group, so the structure is something like that. And we have this extra carboxylic group. In this case, the binding doesn't occur at this carboxylic group, but happens at this one. So alpha, beta, gamma. This is the gamma carbon. This is why we write gamma, glutamic acid, cysteine, then glycine. For the other amino acids, it's totally normal. It's just different at this carbon. So the structure would look something like that. This is the basic structure, and then we have the gamma, the alpha, beta, and the gamma carbon, and then this is the carboxylic group attached to it, and then we will add cysteine, so CO and cysteine is CH2, and we have the thiol group, the SH group, and then we will have glycine. So we have to know that glutathione is a very important endogenous antioxidant in our bodies, and it works as a cofactor with several enzymes like glutathione transferase. So glutathione transferase or glutathione peroxidase, which works on eliminating the toxic peroxidases from our bodies, and so on. Glutathione is found in two forms. We have a reduced form, which is this form, and it's reduced because it has the hydrogen attached, and having the hydrogen attached is a reduction process. And we have the oxidized form. The oxidized form happens when the hydrogen is removed and two glutathione molecules are attached to each other at the thiol groups so that they will form a sulfur bridge. So this is the oxidized form. And we gotta know that the reduced form of glutathione is higher than the oxidized form, because as long as there is a reduced form, it can be oxidized and it can function normally in order to help in the process of antioxidation. So to perform the role of being an antioxidant, there has to be a higher ratio of the reduced form than the oxidized form of glutathione in our bodies. And this is it for the condensation of amino acids. I hope the process was clear for you, and until the next time, I thank you for watching and see you.